questions over any of the papers I handed back, we'll do that. But we are ready for practice test 3. Right? So let me see who I'm missing here.
They're really good at it. They're really good at it. Oh, yeah, they're gonna. Yeah. They're both barely lost. I texted my team down.
No, Evan?
Kind of like something straight.
And,
Kind of like something straight. Nothing against anything.
now this practice test is written out just like the test will be. Alright, and our test is Wednesday, so next time I see you, we have our test.
Jameson's ready.
Alright, so first things first, what is the domain? Well, what am I thinking about every time the question says what's domain? Denominator can't be 0. So let's just check these problems out. The first one has a denominator. So I'm going to say x minus 6 can't be 0, which means x can't be 6. And the bottom one has a denominator. So I'm going to say x plus 7 can't be 0, so x can't be negative 7. Everyone on board? Okay? Now, what's the other rule? Denominator can't be 0. What's the other rule? Whatever is under the radical. So part A, x minus 4 has to be greater than or equal to 0. So x has to be greater than or equal to 4. So part A has 2 answers. Right? C has a radical. So x plus 5 has to be bigger than or equal to 0. And x has to be bigger than or equal to negative 5. Have I taken care of all the denominators and all the radicals? Yes. So what about B? All of this. Because it does not have a denominator, nor does it have a radical. Okay? I swear, you missed that, I'm going to just, I don't know, smack you or something. You can't miss this, okay? You practice. So, all right, number 2. We're going to find the horizontal and vertical asymptotes as well as the holes. All right, so our problem is this. All right, what do I want to do first? Factor. Anything they'll factor. Now, obviously, the top isn't going to factor, but the bottom will factor into what? Minus 4 plus 1. I'm going to do a quick check there, making sure I don't miss that, because if I miss it, I'm in trouble. Nothing cancels. So what does that mean?
No holes.
No holes. So I write none. It'll be just like this, guys. There's going to be an answer blank. You have to write none in the answer blank. If you leave it blank, you're going to miss it. You have to write none.
Question: why couldn't you just repeat that 2 and then cross cancel out the x plus 1?
No.
Do you mean factor a 2 out?
Yeah.
Because that would make x
Oh,
plus 1
plus 2.
half. Yeah, there's no 2 there. I can't factor that at all. It's not factored.
So then if you have a hole, you plug it into that one.
The reduced one, yeah. Okay. Now, where do vertical asymptotes come from? Vertical asymptotes come from the denominator. So I got 2 things down there. X equals 4 and x equals negative 1. Those are my vertical asymptotes. I have 2 because I have 2 things in the denominator. Where does does my horizontal come from? The horizontal come, uh-oh. I want to box these in, but what? I can't, because that's a squared and that is not.
So you gotta add
So I'm gonna have to add in a 0x squared
0 over 1.
so that I can box them in. And I have 0 over 1. Kids, when there's no number there, it's a 1. So we have 0 over 1, which is 0. 0 divided by 1 is 0. And there it is.
There's an x squared at the top and not the bottom, then it would be like all real numbers.
No, it would be no asymptote because you can't have a 0 at the bottom. So it'd be 9. All right, let's look at the second one. I'm gonna go ahead and factor it. So how does my top factor? They're both gonna factor this time. How does the top factor? X
Plus 3
plus 3 plus 2. I love it because when I FOIL that, I get a 3x and a 2x, which is 5x, right? David, are we focused? Focus. All right, how does the denominator factor? Minus 5 plus 3. I'm gonna double check that one. I think that's right also. And then what do we notice?
cancels out.
We're gonna end up then, our problem is going to be x plus 2 over x minus 5. And there's going to be a hole, and the hole is going to be, the x is gonna be negative 3, because that's the one I canceled out, right? And then I'll plug that negative 3 in, so I have negative 3 plus 2, and negative 3 minus 5. So what is that? 1 over 8. Negative 1 over negative 8, but that's 1 over 8. You a lot of times skip fractions there. We're not going to worry about that. That happens. Okay? Now, how about asymptotes? Do I have a denominator left?
Yeah.
So that means I'm going to have an asymptote at 5. And I am going to write x equals 5 so that I don't lose points. And look here, can I box in this time? Yep, I have 1 over 1, so my horizontal is that y equals 1. Right? Joyous?
I just get 5.
What makes the bottom 0? 5.
Oh.
5 minus 5. It's the opposite of your denominator. I think there's one more of these. Yep. So does everything factor here?
Yeah.
So x plus 4, x minus 4, x plus 1, x minus 1. Nothing cancels, which means no holes. And I have 2 things in my denominator, 2 x's. So I'm going to have 2 asymptotes again. X equals negative 1 and x equals 1. This one's negative 1, that one's 1. And I didn't write down my original problem, but can I box in my x squareds? Yep, and when I do, I get y equals 1 over 1. Okay. Now we've got some sketching to do. All right, so the first sketch is piecewise. right here with a solid dot. And I'm gonna keep which side?
Right.
I'm gonna keep that, so I'm gonna get rid of this. All right, now what? What's this? That's a line that has been dropped, so if it were just that, it would go through the origin. But it's down one, so it's down here now. So it's that nice little diagonal line. Drop down one. It intersects right here in an open dot. And I need to keep all of this. So I don't want this. You can leave this squiggly, I'm gonna erase this so you can more clearly see. Look at what we've got. We got a parabola here. We got this little arrow thing down here. Okay? You can always go home and practice this again. All right, now we're just gonna do some sketches. What is this? What shape? Parabola. Remember, half credit for just getting the shape right. And then the other half is gonna come from putting it in the right spot. Be careful. Right one and up two. So right one, up two, label that point, draw in your parabola. Perfect. Right one, up two. Those are the rules. This is almost the same thing. Only what shape is this one? Absolute value V. And it's been moved how? Left one, up one. So negative 1, 1. Left one, up one. Negative 1, 1. And then all right, now this one is a little bit tricky. And it doesn't help the way I wrote it, but this is what it's supposed to look like. Okay? Now, V's and parabolas, I'm good at, I do those all the time. This one I don't do as much, so I'm gonna go ahead and sketch my BFF from memory. What is on my note card? This is on my note card. Would everybody agree that is my exponential? Now I have to pay attention, what is happening with that picture? Up two. So everything is going up two. So where will this asymptote be if it goes up two? At two, right? It was at 0, originally it's at 0, it's going up two. Now this dot is supposed to be at 0, 1, but I'm taking it up two, so where's it gonna be? 0, 3. And then I'm just drawing my shape. My shape doesn't change, only its location. So, some of you, when we were doing the BFF, said, do we have to have the asymptote? Yeah, you do, because that's the floor of the picture. And now the floor is up here, it didn't go all the way down, it's up here now. This one now is we've had one on every practice test where we've had one of these sine or cosines. So again, I'm going to go ahead and draw my regular cosine. The top of it's at 1, the bottom of it's at -1, right? And the cosine does this. That's the normal, that's the regular one. So it has a ceiling at 1 and a floor down here at -1, right? Those aren't asymptotes. I'm just showing what it's locked in between. Now, what's gonna happen, guys, when I take that picture and move it down 2? Then, if this comes down 2, where is it gonna be?
0.
No, if 1 goes down 2, where is it? -1. But that is now the ceiling. Where is the floor gonna be? It was at -1, it's going down 2, so it's gonna be at -3. Now, cosine starts at the ceiling, comes down, and if you're bothered by that, go ahead and put in your midline, and you can see your hills and valleys, they're just dropped down 2. Now, you do not have to have a single one of those lines in your picture. I drew them in to help you visualize. What you do have to have is, that's gotta be labeled -1, and that's gotta be labeled -3. And it's gotta start at the top, because that's what cosines do. Alright, and then this last one, I got wild and wacky. What's that? Square root, that's the one that starts at the origin and goes up and out. What did you do to it? Right, 2. Okay, I got that. What does putting a negative in front of it do? Flips it. So instead of looking like that, which is what it would look like if it were positive, same point, 2, 0, but now it goes down and out. Putting a negative in front of anything is going to turn it upside down. So write 2 upside down. Only if you change the sign on X and we haven't done that yet. We'll do that next. 1.6, I hope. All right, here we go. Now we have our functions to deal with. So we've got 2x squared and oops, cube of x. Is -3x plus All right, what does this mean? What am I supposed to be doing here? Be careful. Yeah, that's a times, guys. That's not an open circle, that's a closed circle. You will never see P of X, open circle, Q of X. You might see this. That means composition, that means put Q into P. But this means straight up multiply. So that's 2x squared times negative 3x plus 1. What does that equal? Negative 6x cubed plus 2x squared. And that's it, done. No more. That's the end. This means put P into Q. So here is P, and I'm going to plug that into Q, where the X is. So take the P function, whatever it is, the whole thing, and put it into the Q in place of X. So negative 3 2x squared plus 1. I got negative 6x squared plus 1. Did I multiply right? That's what you got. Good. Must be right. Alright, I need to take attendance. Alright, what's happening in the next one? Okay. What are we doing for this next one? We're finding P of 2. Alright. Figure out what P of 2 is and tell me. What's P of 2?
It's 8.
Oh, 8.
P of 2 literally means 2 times 2 squared. When you evaluate a function, you take out the x and put the number in. What does that equal?
8.
8. You square first. So 2 squared is 4 times 2 is 8. Now I'm not done. I need Q of negative 1. What is Q of negative 1? Or negative 3 times negative 1 plus 1. I heard somebody say 4. And then what am I supposed to do with those two numbers? Add them. So the answer to the question is 12. All right, P of Q of 0. So where do I start? Q of 0. So if I put 0 into Q, what do I get? Q of 0 is 1. Now I find P of 1, which is 2 times 1 squared, which is 2. We square first. PEMDAS. Exponents first. So that is says find the implicit functions. Okay? What does that mean? What am I supposed to be doing? Solve for y. Now, we had one like this in homework, and a bunch of you missed it. You're getting y by itself, so we're gonna subtract x squared, right guys? That leaves you with negative y squared equals 25 minus x squared. Now you gotta divide everything by negative 1 so that you have plain y squared. But over here then, you're gonna have negative 25 and positive x squared. Right? And then you're going to square root, and look right there, y equals 2 answer blanks. So y equals square root negative 25 plus x squared, which by the way is the same as x squared minus 25. Doesn't matter to me, it's the same thing. Or y equals negative the square root of negative 25 plus x squared. Do these two negatives cancel? No! What did I tell you? These two radicals are always going to be identical. Identical. You're not changing a thing. The only thing you're changing is you're putting a negative in front of one of them. Okay? All right. We just took the whole test in 25 minutes. So tomorrow you have the period, Thursday you have, or Wednesday, whatever day it is, you have the period, okay? And that's it, okay? So some of you are gonna finish in 25 minutes, bring something to study, but everybody is done at the end of the period, okay? Everybody. So make sure you have practice. All right, now what's this number 6? We've never had a number 6. We've only had 5 parts. What this is? Why in the world am I just throwing something brand new at you right now? Any thoughts on that?
You don't like it?
I don't like you. Okay, it's a good idea. What else? Oh. Ooh. I wonder. Now, because of that, I'm going to go through this problem one time. Not going to answer any questions about it. Not going to practice anymore. That's on you. If you want to practice it some more, I'll go through it one time. What it's saying to me is that if I plug n into m, that's what this means, right? N gets plugged into m. This will be the answer. Okay? So stop and think about this thing right here. There are 2 operations happening. If you pick a number like 5, if you put 5 in here, what does this equation do? It multiplies by 3 and then subtracts 7. So the 2 things that have to happen are those, and they have to happen in that order, right? Because we multiply before we subtract. So the first original function, the first thing that has to happen is I have to multiply by 3. So n is the function that takes the number and multiplies it by 3. And then m has to do the other thing. So it's going to take a number and subtract 7. Now, look what happens. If you put this into here, do you get 3x minus 7? Yep, just like you were supposed to. If you put your n function into your m function, you get it. All right, now I'm done talking about that. But what I will talk about is anything else from the other problems on the practice test. So anything else that we need, what do we need to practice extra? Now, we did this last time, and some of you didn't participate, and most of you who didn't participate aren't the ones that got A's on the test. All right? Let's participate in this activity. Mr. Egan.
Can we do more, like part 4, like, I can't remember what it's called, but plugging stuff in.
Yep. So I'm gonna do a couple more like number 4. So I'll make up a couple functions. So a of x is 5x plus 1, and b of x is negative x squared plus 2. Okay, here we go. So why don't we do a of x minus b of x? And then a versus x. And a of 3 minus b of 4. And then b of a of 3. Alright, so we'll do these 4 problems. Because this is what's going to happen on your test. I'm going to give you a couple functions. I'm going to ask you random questions. I'm not going to these exact questions, but they're going to be these kind of questions. So what does this say? What's this telling me to do? So 5x plus 1 minus negative x squared plus 2. It's easy to get carried away. Slow down. Minus that whole thing, right? So what's going to come of that? 5x plus 1 plus x squared minus 2. And because we're all good math students, we're going to put it in descending order. So x squared plus 5x minus 1. All right, now the practice test we just did, that was the times. So I multiply down. If it's a plus, I'm going to add them. If it's a minus, I'm going to subtract them, right? I just do whatever that says to do. All right, now what does this mean? It's literally plug B, the B thing. This is the B thing. Plug it into A, right here. So that's going to be 5 times negative x squared plus 2 plus 1. Whatever b is, take out the x in A and plug it in its place. So what am I going to have there? Negative 5x squared plus 11 plus 10 plus 1. Do here. This is a 2-parter. I'm going to put 3 into A, for x in A. So that's going to be 5 times 3 plus 1, 16. And now I'm going to put 4 into B for x. So I'm going to have negative 4 squared plus 2. Be careful. What's getting squared? Just 4. Just 4. This says negative 1 times x squared. Square first and get 16, and then make it negative. So that is negative 14. Kids, if I were squaring negative 4, it would look like this. That's not what it looks like. There's no parentheses there. So it's 4 squared, make it negative. And then what do I do with these two numbers? Subtract them. So 16 minus negative 14 gives me 30. We're subtracting a negative. 16 minus negative 14, that makes 30. All right, what does this mean?
You gotta plug
3 into A, so let's start with that. So did I just do that? I think I just did that. That was 16, right?
Yeah, plug 16.
And now I plug 16 into be, so that's gonna be -1 times 16 squared plus 2. 16 squared is 256, so -256 plus 2, -254. Didn't mean for those numbers to get so big. Okay? All right, what else do we need to take a look at?
Can we find horizontal asymptotes?
So we want a problem where we have to find the asymptotes and holes?
Yes.
So let's do a couple of those. All right, here we go. What do I always do first? Factor everything. I factor everything, right? Because remember, if there are holes, I have to cancel, right? Which means everything has to be factored. So what can I do to the top?
Take it 2 out.
Take a 2 out. And then what can I do with it? So 2, the 2 is still there, 2, x minus 2, x plus 2, over x plus 3, x minus 3. Okay, well, all that factoring did nothing, because nothing canceled out, but that's okay. That just means I don't have any holes. And it does help me with my verticals, because now I see I have 2 things in the denominator. So my vertical will be, one of them will be at x equals -3 and x equals +3. And then my horizontal asymptote, go back to the original, it's easier to tell from the original, because I can box these in. So that's 2 over 1, which is 2. So my horizontal is y equals 2. All right, is that okay with everybody? All right, now, what about this one? Well, I'm going to start exactly the same way. I'm going to factor everything. That numerator is just like this one, would you agree? So I'm just going to skip right to that. How about my denominator though? This denominator is different. Nobody's factoring for you on Wednesday. You have to
X
be able
minus
to
4,
do it.
x minus 2.
I heard a -4, -2. Why did he pick 4 and 2? Because they multiply to give you 8. And -4 and -2 are going to add up to -6. Now, what is this? We can cancel this time. And that means we're going to have a hole. And the hole will be at wherever we canceled, which is where x is 2. And we're going to plug that in. So I have 2 times 2 plus 2 over 2 minus 4. I'm plugging 2 in for my x's. So it looks like my top is 2 times 4, 8. I got -4. Did anybody else get a y value for -4? Vertical asymptotes. Come on, you can't miss it. Look at your denominator. Where is your vertical asymptote? X equals 4. It's your vertical asymptote. How about a horizontal? Well, be careful. This is a 2x over an x. So that one's also at y equals 2. You can also go back to the original. Look at the original. 2x squared over 1x squared. Okay, Jennifer? All right. Okay.
We did the one where it's like, we graph it, but it's like, the greater and less than side, and you graph like.
Piecewise function?
Yeah.
Yeah. What does your test look like, guys?
Exactly like that.
Exactly like what we just practiced. This is the only practice test. Yep, so you're gonna have to be able to do it. So let's do, x plus 2 and negative x squared. X is bigger than times. So my broken thing is right here. If you guys encounter a marker that doesn't work, please throw it away, don't put it back. There's where the break is, right? What does that look like? What does that look like? It's a line, and it's moved up to? Here's my line. There it is. It intersects right here with an open dot. And I need to keep that part of it right there. I'll get rid of this part. So far, so good. Tricky again, what's this? Upside down parabola. Why is it upside down? Because there's a negative in front of it. So he's going to look like this. And he intersects right here in a solid dot, right? Which side do I keep? Left. I'm going to go ahead and erase my squiggle. You don't need to do it, but I'm going to. And that's what I've got. So I've got that half line shooting out like that, and then part of the parabola down here. Okay?
Can we do one implicit?
Huh?
Implicit.
All right, you good on this?
Yeah.
Good here? All right, so now I'm going to I'll do an implicit function. So let's see, 2x squared plus y squared equals 18. And we want the implicit functions for this. So what do we need to do? Subtract. We need to get y squared by itself. And this one is easier because there's no negative to worry about. But if that had been a minus right there, you have to then in your next step get rid of that, right? We're ready to go. We're going to square root both sides. So y equals the square root of 18 minus 2x squared and the negative square root of 18 minus 2x squared. Alright, so one more and then we'll look at your quizzes and homework that you might have questions about. Let's see, what have I not done? I didn't do any domain problems, but we can do it. What about something like this? Exactly. This time, there's two numbers that your denominator can't be, right? Because if you factor that denominator, then x can't be -3 and x can't be +3. Would you agree with that? Okay, so that takes care of the denominator. What's the other part? The radical has to be bigger than or equal to 0, so x has to be bigger than or equal to -7. Because when we do domain, we cannot have a 0 in the bottom, and we have to have greater than or equal to 0 under the radical. Nope. Yeah, it would like impact maybe a horizontal asymptote or something like that, but no, not in terms of domain. No, domain, I look at two things.
So that
Denominator
2 in front should stay there.
Yep. Then that, remember, when I'm doing domain, what do I care about? What is under the radical and what is in the denominator. If it's not under the radical or in the denominator, I'm not worried about it when it comes to domain. All right, that's it. There, we need to talk about your quizzes that you just got back and the homework you just got back. Does anybody have a question about either one of those two things? Remember that the practice tests are in Canvas. You can print new ones, you can put them in Notability, and you do them again. And I would suggest that you do at least one between now and Wednesday. No questions about anything, Manny?
Yeah, there's not gonna be like a separate part for like the specific functions like we did on.
No. Manny, what does your test look like? Just like the practice test. Now, does that mean that you still need to know your BFFs? Yeah, because when you go to do a piecewise function and it's got an x squared in it, or those ones like we get sine x plus 1, you have to know what the sign looks like and then move it up 1. So, but no, there won't be, there won't be BFF specific questions.